Okay, we are going to continue with skeletal muscle. I may just review for a minute, only because I don't, some of my past recordings, it's blacked out for about the first 20 to 30 seconds. So if I am stalling, it's true. But just to review, in a previous video on skeletal muscle, you should review some of these basic terms on types of muscle contraction, especially concentric, eccentric, and isometric, and remembering the difference because these are used in rehabilitation and chiropractic and physical therapy. These are used quite a bit to change posture and help to elongate muscles or shorten muscles when needed. And you should be familiar with the terms origin, insertion, agonist, antagonist, and synergist, and innervation. Because innervation is really important when we get into the neuromuscular junction. Now, when we look at muscle and skeletal muscle, we'll see that in its smallest microscopic portion, it is made up of skeletal muscle fiber cells. And each of these skeletal muscle fiber cells are surrounded by an endomysium. So what you'll see here is each muscle fiber is surrounded by a connective tissue called an endomysium. But then we have, if we go back here, we have a bunch of these little endomysiums surrounded by another layer called a perimysium, and this is referred to as a fascicle. But then you have a bunch of fascicles in here. Here's a fascicle, and here's a fascicle, and here's a fascicle, and here's a fascicle. And again, within each fascicle are a bunch of those muscle fiber cells surrounded by endomysium. So when you have a bunch of those fascicles, they are surrounded by an epimysium. Okay? So you will have a group of muscle fibers surrounded by a perimysium, and that's called a muscle fascicle. And again, we can see that here. So let's say here's a muscle fiber cell, then you have endomysium around it, then you get a bunch of these groups here. This is referred to as an entire fascicle. Then you get this fascicle, and this fascicle, and this fascicle, and this fascicle, all of these fascicles, okay, and these layers around it is referred to as a perimysium. The layers around here, these are the endomysiums, okay? So surrounding the entire structure all the way around, that's your epimysium, which we see here. Now, muscles contract. They transmit their contractile force to the tendon, and you can see the tendon is going to attach to bone. And the part of the bone that tendon's attached to are the periosteum. Now, if the contraction is super hard, sometimes tendons rip off bones. Extremely painful, usually requires some surgical attachment. Sometimes these muscle fibers in here just stretch beyond their normal anatomical limit. When muscles stretch beyond their anatomical limit, we refer to it as a muscle strain. And you have different grades of muscle strains. When a ligament tears, it's called a sprain with a P. So there's a big difference between strain and sprains. Strains involving tendons, muscles, typically heal faster because they do have a better blood supply than ligaments. Sprains. Okay, when tendons, we said, are a little bit more elastic than muscles. Muscles are elastic. Tendons are inelastic. That's what makes them so strong to pull on the periosteum of the bone to create movement. A broad, flat tendon is called an aponeurosis. An aponeurosis. You'll see that term aponeurosis associated with the biceps muscle, like the biceps brachii. The insertion is called a bicipital aponeurosis. One of the widest muscles of the back, called called the lats, or the latissimus dorsi. The latissimus dorsi has an origin from the lower 6 thoracic vertebrae, all of the 5 lumbar vertebrae, some of the sacrum, and some of the ilium. It's so wide, that origin, they call it the thoracolumbar aponeurosis. So an aponeurosis is really a very broad, flat tendon. Fascia, on the other hand, fascia is the term that it describes the sheet of fibrous connective tissue that exists between the skin and the surrounding muscles and organs. Okay, that's fascia. Okay, good place to take a break. When I come back, we will get into the neuromuscular junction, or the NMJ.